Welcome to qnawire.
Not being artist, this was a tough diagram. So go ahead and look at problem 247 so you can see a better problem here. Well, let's take a look at the problem. The radar tracking antenna oscillates around its vertical axis according to theta equals theta initial times the cosine of the constant circular frequency and t. And 2 theta initial is a double amplitude of oscillation. Simultaneously, the angle of elevation at this, hang on a moment, having a little memory issue. I just need to see, I think it's phi. Yeah, okay, so that's going to be phi is increased in the constant rate of phi equals k. Determine the expression for the magnitude A of the acceleration of the signal horn as it passes position A and it passes the top of position B, assuming that theta equals 0 at that instant. Okay, let's see if there's any chance I can figure this out. Okay, so the position vector in a Cartesian coordinate system. Okay. There'll be a lot of writing on this one. Okay, so R B okay. And then derive over time 2 times. Okay. And then negative. Okay, I think I got all that. I just want to verify I've got it. So I got too many of these here. And this should be cosine of. I always have to check these because it gets real easy for me to change these. There we go. And then using equals 0, we'll get the following. Are you ready? Can't fit that one on there, so I'm going to go to my next line. Minus, start my minus over here. Okay, and then my AY, see if I can write a smidge smaller here. I can't really. Plus, okay, and then A, okay, and then now we're going to calculate absolute value. Okay, so this is going to be a long one. I'm going to be very quiet so that I don't make dumb mistakes. Continue. Minus. I can't fit that on there, so I'm going to go here. Plus, 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 minus. This is maybe the longest thing I've ever had to write in this venue. Minus, Okay. And then I've got to put this cosine theta down here. Hoofda. And now I get to do the same thing for y. Another huge amount of writing. Another moment of me being quiet so I don't make dumb mistakes. Okay. And then I'm continuing sine, cosine, and then it's going to be plus 2, and this continues as sine squared of theta minus, then I'll have plus, and then minus, phew. Okay, and we add them, and we can see that as many terms cancel out, and we will end up with we're going to use sine squared x plus cosine squared x equals 0. We're going to get the following. minus and then we'll get a z squared Okay, and adding these expressions, we'll get the final result for the magnitude of this um, acceleration. Plus, and then use the given results for theta equals t, and then I'm going to get the following. Let me switch colors for this. Okay, plus 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 and plus. Let's see if I can fit this one on here. Oops, that's a minus. Okay, I'm going to go to the next page. At point A, angle theta equals negative theta 0 equals the cosine of WT equals negative 1, and the sine of WT equals 0. So we're going to get the result for A. We'll have the square root of B times K4 plus W4 And then for B, was that big B or little b? I don't remember. At big B, we're going to do that this equals 0. We're given that. And this will equal pi minus 2. So the cosine of this equals 0. And the sine of this equals 1. And the sine of WT equals 1. So that will get me A1 will equal the square root, and I've got B of k fourth plus 4k squared theta 2 to the 0, or initial. So here's my answer for B, and here's my answer for A. I think I got those. Let's hope for the best.